Hi folks. Today I'm going to talk about a new template that we've rolled out called the network chat. The way this works is you'll be able to give this study any network configuration you want, and you'll create that network as a chat room for participants in your study. So if you have a network of 3 participants connected to one another, you can do that here. If you have 10 participants connected to one another through you know, um, a hypergraph or a simplicial complex, or you run in the mill dyadic graph where one person is just connected to one other person on an edge. You can do that here. It's very flexible. I'll talk to you all about it in just a second. But the way you can find it and play with it yourself is under the templates. So if you go to your research team page, add new clone experiment, it's still going to show up here by the time this goes live. So you'll feel free to clone it, experiment it, play with it. And let me show you how it works. So let me go over here to the network chat. Okay. So all you have to do to make this work for your experiment is to set the matrix. So determining what the network matrix actually is. So let me just tell you what chat channel matrix is. So it's line 5 here is player 1. Player 1 is on channel 4 and channel 1. Player 2 is on channels 1 and channel 2. Player 3 is on channel 2 and 3, and then player 4 is on channels 3 and 4. Now, I'm not saying edges because I don't want people to think that it's just player 1 can only that each edge can only have 2 people on it, where it's just player 1 connected to player 2 connected to player 3. Instead, any number of people can be on these channels, like a radio channel. Anybody can be tuning in to channel 4, anybody can be tuning in to channel 1. So if anybody wants to be, if you want to have player 1, 2, and 3 on one channel and player 4 on another channel with player 3, you can do that. It's just say that we want to do this. Player 1, player 2, and player 3 are all on channel 1. Player 4 is on channel 2. Let's just say player 3 is also on channel 2. So now in this configuration, 1, 2, and 3 are chatting in one chat room, and then players 3 and 4 are chatting on a second channel. So this is a very flexible way to create very complicated networks in your experiment. You can do it in a very traditional way where players 1, 2, 3, and 4 are just on dyadic edges where it's just 2 people talking. Or you can be very complex. Again, if this supports hypergraphs where you have any number of people on one edge, and simplicial complexes where you have any number of people on any number of edges at the same time. So let me just show you a couple of limitations here. In this case, you have to know how many participants you have in your experiment. If you don't know or you want to be flexible about it, you can create a network generator. So that will take any number of participants that you get for your study and then create some sort of functional network. So things like line networks where people are just connected to their neighbors, or circle networks, which is like a line, but it's connected all the way around, or a star, or a lattice network. All these things you can do programmatically. So if you don't know the number of people that you'll have in your experiment, you want to be able to do a network, whether you have 5 or 7 or 10 people, you can do that as well. You just have to write your own function that creates this chat channel matrix function. So let me just show you how this works. So let me go back to this original design here where player 1 is connected to players 2 and 4. Player 2 and 3 are connected, and player 2 is connected to 1. So this is just a classic circle network. So here we go. Just save it here and quit. This is all good. And go to the demo tab. So I need 4 participants. I'm expecting a network of 4. I'm kind of screwing around with my experiment a lot, so I need to actually see only 3 tabs opened because I inappropriately closed one of my tabs earlier. I didn't tell I was over. So I had to add subject 1 back in just by copying and pasting the URL and changing it to subject 1. So now you can see I have this chat system where this is player 1. Let me move this player over here. So player 1 is on channel 1 and channel 4. Haven't said anything yet, so let me just say hi channel 4. And then player 2, not on channel 4, doesn't see it. Player 3, not on channel 4, doesn't see it. Player 4 is on channel 4, and they get this flashing box that says, hey, there's a message here on channel 4. Look over there. I see the message from channel 1. So, I player 1. There we go. And player 1's going to get back over here. So this is the basic interface. So this is channel 1, I guess. You can see the top, channel 1. Player 1's on channel 1. So that's the basics of how this particular interface works. This is not a game. This is just a chat system, so there's no thing to win. Let me just close the experiment here. When you're testing it, use the quit button. Otherwise, you'll end up like I have, where I get 3 tabs open instead of 4. So I always use the quit button. Okay. And now, just to show you where the data exists, so I still think it's running. So let me refresh the data. There we go. So when you go to actually get the data out, you can see here in the results, this is the ones that I just did. The messages come out here in the to field. So hi, channel 4. As you see, I have the %20. I'm not cleaning out the HTML, the ASCII characters. See here, I say hi player 1, hi channel 1. So the more I chat, the more data comes out. But this is automatically being saved in this experiment, so you don't have to do any kind of special data saving to get the data on who sent a message to what channel at what time in the study. And you can see this is all my data from me. Okay. If you have any questions or have any issues with this, let us know. We're happy to help troubleshoot, happy to help customize this. And if you'd like to see anything else on our Tinker Tuesday, let us know. We're happy to feature your request. Thank you.